Every certificate that secures a website is signed by some certificate authority. The uncomfortable default is that almost any trusted authority, anywhere in the world, is technically allowed to issue one for your domain. The thing at stake is the certificate itself, the small credential that lets a browser show the padlock, for example. If the wrong authority mints one, visitors have almost no way to tell. Your defense lies somewhere you already control, your DNS zone, the set of records that answers questions about example. It turns out you can publish a record there that authorities are obligated to read. That record is the CAA record, Certification Authority Authorization. In one short line, it flips the whole model from open to allow list, naming exactly which authorities you permit to issue certificates for your domain. Someone has to write that record, you, the domain owner. This is a rare kind of control because a single small entry you publish reaches out and constrains the entire public authority ecosystem at once. The record can carry more than a list. One optional tag names an address that should receive a report whenever an authority is asked to issue something your rule forbids, turning the gate into an alarm. Downstream sits the browser, the party that will eventually trust whatever certificate exists. Notice its position. By the time the browser is involved, the certificate is already made, which shapes what this defense can and cannot do. And here is the antagonist, some other authority not on your list that gets tricked or compromised into issuing for your domain. Let us follow one honest request and one hostile one through the whole mechanism. It starts with you. As the domain owner, you add a CAA record to your DNS zone. In plain terms, it says, only these named authorities may issue certificates, for example, and no others. Look closely at the syntax. Each line is a tag and a value, the issue tag followed by the domain name of one authority you trust. Add a line per authority, and that set becomes your allow list. Now the mechanism comes alive. Some authority receives a request to issue a certificate, for example, Before this record existed, it would simply check the applicant and issue. Now it has one more duty first. That duty is mandatory. The authority must query your DNS and look up the CAA record for the exact name it is about to certify, walking up to parent domains if the exact name has none. Your DNS returns the record and the authority reads your allow list. It now compares its own identity against the names you permitted. This single comparison decides whether the certificate is ever created. Take the honest case first. This authority is on your list, so the check passes. It goes ahead and issues the certificate, for example, exactly as it always would. Nothing here feels different to anyone. Much later, a visitor arrives and their browser is handed that certificate. It validates normally and the padlock appears. The CAA record did its work long before this moment, back when the certificate was born. Now the hostile case. A different authority, one you never listed, is tricked or compromised into issuing, for example, This is exactly the disaster the whole system is meant to prevent from ever happening. But it is bound by the same rule. It queries your DNS, reads the CAA record, and finds its own name absent from your allow list. Obligated to obey, it refuses, and no certificate is ever minted. And because you added the report tag, the blocked attempt is not silent. The authority sends a notice to the address you named, so you learn that someone tried to obtain a certificate they should not. One record reaches wide, a CAA on example. Applies to the domain and everything beneath it, so a subdomain like shop. Example, inherits the same rule unless it publishes its own record to override. Here is the crucial subtlety. All of this happens at issuance time, enforced by the honest authority. It is not the browser checking at connection time, so it prevents a bad certificate from being created, not merely from being used. That distinction separates CAA from things like key pinning, which reject a bad certificate at the browser after it already exists. CAA aims one step earlier, stopping the bad certificate from ever being signed into existence at all. Worth knowing, there are 3 tag types. Issue names authorities allowed to make normal certificates. IssueWild controls wildcard certificates separately, so you can be stricter about those, and IOTIF is the reporting address we just used. The whole scheme leans on authorities actually obeying. That is not just goodwill. Checking CAA before issuance is a binding requirement in the rules every public authority is audited against, and violating it threatens their trusted status. There is a soft spot. The rule is only as trustworthy as the DNS that serves it. If an attacker could forge your DNS answers, they could hide your CAA record, which is exactly why signing it with DNSSEC matters. And one honest limit: CAA does nothing about certificates misissued before you publish the record. It guards the future, not the past. Still, it is cheap and set and forget, one of the few ecosystem-wide controls a domain owner holds. So the full picture: you publish a CAA record in DNS naming your allowed authorities. Every honest authority must read it before issuing. Listed ones proceed, unlisted ones must refuse, and optional tags report attempts and cover wildcards. Thanks for watching. Next time you set up a domain, remember that a single CAA record quietly tells the entire certificate ecosystem who is allowed to speak for you. Cheap, set and forget, and worth it. Follow how it all runs for more. See you in the next one.